Standard to the vertex form. So the standard form, we mean that it looks like ax squared plus bx plus c, and the vertex form we mean y minus k equals slope, which is a, times the quantity of x minus h to the second power. So we are going to change this standard form into some form like this. So first thing you're going to do, well, the process is pretty much the same as completing the square. So we're going to look at the coefficient of x, which is negative 10, divided by 2. You can't really see this one. Divided by 2, and then which is negative 5. And then square that number, that's going to be 25. So that's the number that we're going to add to this equation, which is y equals x squared minus 10x. I'm going to add that here, plus 25, but at the same time we're going to subtract it so that we can keep this equation original, because this is just 0. So this equation and this equation are exactly the same. If I just add 25, that's going to be different from this guy. Now, this is perfect polynomial, so we can simplify or make the expression simpler, looking like x minus 5 to the second power. Now we have 23 minus 23 here. Now adding 23 to both sides, we have y plus 23, which equals x minus 5 to the second power for a point, the opposite of 5, just like this, right? These are opposite, so we get opposite of negative 5 and opposite of k, which is negative 23. So what if we have some other standard form that you cannot divide it by 2? For example, let's say negative, I don't know, 11, x plus some random number, I don't know, 7, right? You do the same exact process. So the coefficient of x is negative 11, so we're going to divide that by 2. We get negative 11 halves, right? Then square that. That's going to be 121 over 4, right? So that's the one that we're going to add to the original equation. But at the same time, we are subtracting the same number to keep it original. I'm going to change this 7 into, I'm going to multiply this by 1, which is 4 by 4 over 4. That's going to give me 28 over 4. I just changed this just because I just wanted to have the same common denominator. Now paying attention to the first 3 monomials. Those are the perfect polynomials, so we're going to get x minus 11 over 2 to the second power minus, that's 121, minus 121 and 28, that's going to be 93. Is that right? 93, yeah. So 93 over 4, that's the one we're going to add to both sides. So we have y plus 93 over 4, which equals x minus 11 over 2 to the second power for a point opposite of negative 11 over 2, or minus 11 over 2, and opposite of 93 over 4.